Hey guys, Mr. Milton here. Today we're going to talk about linear inequalities. At the end of this video, you should be able to show all solutions to a linear inequality by graphing, and you should be able to explain what a solution looks like to a linear inequality. Okay, remember from our inequalities unit that we can already show the solutions to an inequality. So for example, we have x is greater than 4. If we want to show or solve this, then what we would do is we'd make a number line. Okay, I'm going to put 4. X is greater than 4, so we use an open circle to show that 4 was our boundary but not a part of our solution. And because it's at greater than, we shade it to the direction of numbers greater than 4. Okay? An inequality has infinitely many solutions. Okay, but we don't just write that every time because it's important to know where those solutions start. Okay? And that's why we need to graph them to show the solutions. Alright, so that's old stuff. Hopefully you have that in the back of your mind somewhere. Alright, so here's some new stuff. In the inequality above, how many variables does the inequality have? You'll notice that it only had one variable, x, so 1. And the solution looks like one number. Okay. Today we'll be working with inequalities involving two variables, which means that the solution will look like an ordered pair. Okay, x comma y. Okay, so it says show all solutions to the following inequality. Okay. Before we do that, we'll look at this. It says determine if the given point is a solution to the inequality. So we're given this inequality, y is greater than or equal to 1/2 x plus 3, and we're given the point 0, 0. We want to know if it's a solution. So what we're going to do is we're going to plug this point in, 0, in for y, greater than 1/2, 0, plus 3. So 0 greater than or equal to 3. The answer is no. 0, 0 is not a solution. Okay, given the point -2, 7. So again, plugging it into this inequality here, I'm going to plug 7 in for y, greater than or equal to 1/2 -2 plus 3. So that gives me -1 plus 3 is greater than or equal to 7. So 7 is greater than or equal to 2. Is that true? Yes, it is. So it is a solution. And then we're given the point 45, so 5 in for y, greater than or equal to 1/2 times 4 plus 3. 1/2 times 4 is 2, 2 plus 3. Is 5 greater than or equal to 5? Yes, because it's equal to 5. Okay, so that's one way that we can see whether a ordered pair is a solution to this inequality. The other way that we can see is we can graph the inequality and test its points, and this is the way that we'll probably do it more often here. Okay, as we graph, the process is almost exactly like graphing lines. So as we graph this, 1, 2, 3. Okay, my y-intercept's 3. My slope is 1/2, so I'll go up 1 over 2, up 1 over 2. I could go down to the left 2, down to the left 2. Keep it positive. Okay. All right. And so now I make my line. Okay, as you make your line, you have to think about something, whether our line is solid or dotted. In this case, it will be solid. Okay, our line is solid because it's or equal to. So if it's greater than or equal to or less than or equal to, our line will be solid. If it's just greater than or less than, then our line will be dotted or dashed. Okay, well, that'd be a way for us to see that our line is not a part of the solution. So then we have to talk about shading, because y is greater than. When it says greater than, we're able to shade above the line. Okay, the line separates the solutions from the non-solutions. And we need need to shade on one side of your line. The shaded region represents all the solutions to the inequality. So now, all that for this. If we're given this inequality, we could graph this from the beginning, and then we could say, okay, is 0, 0 solution? And as we have 0, 0, it's here, it's A. Say, is 0, 0 where it's shaded? No, so it's not a solution. What about negative 2, 7? 1, 2, 1, 2, 3, 4, 5, 6, 7. Negative 2, 7 is here at B. Is that a solution? Yes, it's where we shade it. What about 4, 5? 1, 2, 3, 4. 1, 2, 3, 4, 5. 4, 5 is here. Okay, is that a solution? Yes, it's on our solid line. Remember that because it's or equal to, that line is solid, meaning it's a part of our solution. And so then we could test those 3 points as solutions much faster than plugging in these values and evaluating the inequality. Okay? All right. Let's do some more on the back. Okay. To determine which side to shade, you must have your inequality in slope-intercept form. Okay, so make sure you have your inequality in slope-intercept form. Okay, remember that's y equals mx plus b. Okay. If the symbol is greater than, so whether it's greater than or equal to, then you shade above the line. If the symbol is less than or equal to, then you shade below the line. All right. Just all centered together. Okay. All right. So we have y is greater than negative 2/3 x plus 7. This is in slope-intercept form. That's good. Our y-intercept is 7, so I'm going to go there. 1, 2, 3, 4, 5, 6, 7. Okay. My slope is negative 2/3, so I will go down 2 to the right 3. Down 2 to the right 3. Okay. Now, notice that our line, our sign is just greater than. Y is greater than. So, it will not be a solid line. It will be a dotted line. I'm going to dot my line. Okay, or hash it, however you want to call that. Okay. But notice this is different than a solid line. It indicates that the line is not a part of the solution. It's dotted. Okay. All right. And then y is greater than. Greater than means we will shade above. We'll shade above this line. Okay. And here it says give just one solution to the inequality. Notice there's a bunch of them. I'm just going to say that, hey, this point's the solution. 7, 7. Okay. But realize that the solution cannot be on the dotted line. Okay. All right, I'm going to have you guys do this one. So y is less than or equal to 5x minus 1. Do that problem, bring it in, complete it. Give me just one solution to the inequality, just as we've done here. All right. So looking at 3 and 4. Okay, here and here. We're given number 3, 4x plus 3y is greater than or equal to 9, and 4x minus 6y is greater than 24. What do we have to do first for these problems? We want to put them in slope-intercept form. Y equals mx plus b form. Okay. So we're getting y by itself. So for the first problem, we'll subtract 4x from both sides. Get 3y is greater than or equal to negative 4x plus 9. Get y all the way by itself by dividing by 3 on both sides. And so our new inequality will be y is greater than or equal to negative 4/3 x plus 3. Alright, so now we're going to graph this. Since it's in slope-intercept form, we can just follow the y-intercept at 3. Our slope is negative 4/3, so 1, 2, 3, 4 over 3, 1, 2, 3. 1, 2, 3, 4 over 1, 2, 3. 1, 2, 3, 4 over 1, 2, 3. Alright, and so that's our line. It's or equal to, so our line will be a solid line straight through here. Okay. Alright. And it's greater than, so we're going to shade above. Okay, and we don't need to color it in like a piece of charcoal or anything like that, just enough for us to know that it's shaded. Alright, so the question is 3, -1 a solution? Well, let's see. 1, 2, 3, -1. That is a point on the line. Our line is solid, so the answer is yes. Okay. Now we have to do the same thing for the second inequality. The second inequality. 4x minus 6y is greater than 24. So we are going to subtract 4x from both sides. Okay, and we get negative 6y is greater than negative 4x plus 24. To get y by itself, we have to divide by negative 6 on both sides. Remember that with an inequality, when you multiply or divide both sides by a negative number, the sign has to flip. So now instead of being y is greater than, it'll be y is less than negative 4. Negative divided by negative is going to be 4, 6. X minus 4. We'll simplify that. Y is less than 2/3 x minus 4. Okay, so we flipped the sign because we had a negative. We divided by a negative number. All right, so now it's in slope-intercept form. My y-intercept is negative 4. 1, 2, 3, 4. My slope is 2/3, up 2 over 3, up 2 over 3, down 2, left 3. Okay. And my sign is just less than. So, because it's not or equal to, my line will be dashed or dotted. Okay. Okay. Less than, I'm shading below the line. So, Got it? Now the question is 6, 0 solution. 1, 2, 3, 4, 5, 6. 6 is on the line. The line is dotted. 6, 0 is not a solution. Okay, so there you have it. You have one graph I'd like you to complete. Bring it to class, complete it. Make sure you worry about the, whether the line is solid or dotted, where to shade, and then give me one solution. All right, see ya.